This is Pvneo's fastest workflow. You draw the roof straight onto satellite imagery, and Pvneo turns it into a 3D model you can design on. By the end, you'll have an analyzed roof with panels and a first-year production estimate. I've already created a project and completed the wizard, exactly as we did in the welcome video. So we're looking down at the site in satellite view, ready to draw. I'll start with the Draw Roof Face tool. For the main roof, I draw a simple rectangle over the largest plane, clicking corner to corner and closing the shape. Then I add a smaller roof face for the secondary section, the same way. The idea is to trace each distinct plane of the roof as its own face. Real roofs aren't always clean rectangles, so Pvneo gives you tools to shape them. If a face has an edge you don't need, you can delete that edge to simplify the outline. And where one face you drew actually covers two planes, you can split it into separate faces, so each part of the roof can carry its own height and tilt later. As you work, the canvas shows angle and length measurements on every edge. If they get busy, there's an option to hide the angles and lengths, giving you a cleaner view while you draw. Next, obstructions. I draw anything panels can't sit on, or that casts shade. Chimneys, vents, skylights. These matter later because they affect both the sunlight analysis and where panels are allowed to go. So far, everything's flat on the map. Now I switch to 3D mode, and Pvneo extrudes the polygons for me, lifting the faces up into a real 3D model. Orbit the view and you can see the roof stand up off the ground. First, I will set the height. I multi-select all the roof faces, then click one to open the properties and set the height so the whole roof is placed at the right level in one go. Now the tilt. To pitch a roof face, I select its middle line and grab the arrow, then drag it up until the face slopes the way the real roof does. If you know the exact tilt angle, you can type it straight into the properties instead. Then I do the same for the other roof faces, so every plane has the correct pitch. It's worth adding the surroundings too, things like nearby trees, since they can shade the roof at certain times of day, and Pvneo will factor them into the analysis. And don't forget to save your work before moving on. Now I switch to design mode and run the irradiance simulation. Pvneo maps how much sun reaches each part of the roof using the shapes, tilts, obstructions, and surroundings we set up. The warmer areas get the most sun. And as I move the mouse across the roof, I can read the solar axis at any point, so I know exactly where panels will perform best before I place a single one. To lay out the panels, I select the SmartFill tool, and Pvneo automatically fills the usable roof with an optimized layout in one step. You're never locked into that, though. You can also place panels manually and adjust them, adding, removing, or nudging panels until the layout is exactly what you want. Take a moment to get familiar with the toolbar. You'll be switching between Select and the Panels tool a lot. And if getting around the 3D view feels awkward at first, there's a 1-minute video in the description on how to pan, zoom, and orbit inside the 3D view. Also, a reminder to click the Save button from time to time. Once the panels are in place, I press Simulate to get the first-year production, the estimated energy this system will generate in year 1. That's the number your client cares about, and it flows straight into the proposal. From a flat satellite image to a full 3D roof, analyzed and paneled with a real production estimate. In a later video, we'll turn a design like this into a proposal.